For this week's Preppin data, we're solving a variant of one of my favourite problems, which is the knapsack problem. So basically what we have is a list of orders and their size, so how many bars of soap are there in each order. And then we've got some box sizes, so how do we ship those orders out to our customers in a way that minimises the leftover space in each box, basically. So we have two outputs this week. The first one is to take each order number and say how many of each size box we need. So let's work on that one first, and then I think it'll probably require a second video to go through the second output, but we'll see how we go time-wise. So let's go into Tableau Prep. So here is that order information. We've got our 7 orders, and we're just going to add on to that a dummy column. So that's just got 1s in it. And then we've got our box size input as well, and we've also added a dummy column onto that, so that when we join those two things together, then we get, for each order number, we have each box size as a row. Now that's really going to help us because we want to have a column for each box size. So now we can do a rows to columns pivot, so that we get that information as columns rather than as the rows. So that's a great first step. But before we do that pivot, there's a couple of bits of information that I want to get out of the data whilst it's still in this structure. So if we think about it, when we pivot, these numbers here relating to the box size, they're going to be the new column headers. So we won't have any information anywhere within our data what the box size actually is. We would have to, in any future calculations, hard code those values. So to stop us having to do that, we're going to use some LODs. I'll talk through those first before I come back to this dummy field that I will talk about in a minute. So first of all, to have our biggest box, then we need to do a fixed LOD across the whole data set and return our max box size. So that gives us a column that just has the number 120 repeated in it, so that for every row, if we need to reference the biggest box size, we have it there rather than hard coding it in ourselves, and that keeps it all fresh and dynamic, our workflow. So then for the smallest box, we use a similar logic, but we just use the minimum instead. So then if we're trying to find this number 24, our middle box size, that took me a couple of minutes to remember that the function of median exists, and that returns to us our lovely middle value, our middle box size of 24. So obviously these steps to get these numbers out would be different if we have more box sizes, so that's when our workflow wouldn't be quite as dynamic, but for now this works if there are only 3 box sizes. So the other thing that I've done within the step is to look at our dummy field and to say, basically, we want to know if we divide the order size by the box size and keep that as a whole number, then what's the upper bound of how many would we need if we were just using that box size? Or basically, if it's less than 0.5. So for example, where the order size is 60 and we have a box size of 120, then we would never consider using that box because there's definitely a more efficient way to do it. We don't want our box to be 50% empty. But in other cases, you know, this is giving us an upper bound of the worst case scenario where the box is less than 50% empty. So if we look at a few examples to understand that, we'll look at the 120 ones. Oh, let me just click back on there. We'll look at the 120 ones. So you can see the numbers, the order size is getting progressively larger. And for 48, because that's less, that would be more than 50% empty if we were to use a box of 120. We've got a 0. But then once it gets to above 60, then we've got a 1 there. So this is just to help us when we start making calculations later on. So we pivot that from our rows into columns, as we kept saying that we were going to do. And then we're going to say we're looking at an example of order number 7, which has 801 soaps in it. At the moment, we're saying that we would use 7 boxes of 120 size. So that would be kind of the worst case scenario of what we would do. but let's see how we take that worst case scenario. And we start from the larger boxes and work our way down to the smaller boxes to reduce those numbers. So if we take our 120 field that we're updating, remember that was a 7 before, so we're saying that if when we multiply our 120 fields, so that's a 7 at the moment, by our biggest box, which is 120, so that's 840, and we minus off the order size, then that would give us 39, because we've got 840 minus 801, 39. As that's bigger than 0, as we have leftover space in that box, we're going to say let's minus 1 from that field. Let's not have, you know, that extra space in our box. Whereas if we're thinking about a field like order number 5, an order like that, then we've got 125 order size there. And so when we minus off the order size from 120 times by 1, then that's a negative number, and we wouldn't therefore want to minus off that box. That box is full, so we want to keep it. And also, if our current number of 120 boxes is 0, we also don't want to minus off a number, because we can't have a negative number of boxes fulfilling that order. So once we've done that, then we get our, that looks much more reasonable, how many boxes we should use of 120 size. So then we're going to just do a little calculated field to say how many soaps are then remaining once we've used all of our 120 boxes, and we just do order size minus off 120 times by whatever number is in the 120 field, and so we get our little remaining number there. That leads us to be able to calculate our how many 24 boxes we're going to use. So we're just going to use a floor function by dividing that remaining 120 by the medium size box, which is 24. So then we get much more reasonable numbers for our 24 fields as well. If you see there, it goes down, that one from 33 down to 3. So that's much better. And then we do a similar thing there, where we're just going to iterate again and calculate how many is remaining after 24. And then for our 6, instead of a floor function, we're using a ceiling function, so we're kind of rounding up, because we definitely want all the soaps to be able to be packed. And we're doing a similar thing where the remaining 24 are divided by the smallest box, which is 6. And then we get all the values for our 6 as well there. We're just doing a bit of renaming fields so that it matches our output. And then we're finally just going to remove that a few more fields, those ones that we calculated back here, to make it easier, so that it matches the output that is in the challenge. So hopefully that makes sense, that logic, and you can get to the same answer too. Join us in another video for calculating the second output.